This one-point lesson is designed to help you decide between the Z and T statistic when conducting hypothesis tests about the mean. Problems often do not explicitly state which statistic is appropriate. So how do we know which one to use? This lesson covers three main points to help you decide which one is appropriate. First, we'll talk about the main difference between the Z and the T hypothesis tests. Then we'll look at some of the conditions for which the Z hypothesis test is appropriate. Then I'll show a few examples to help test your understanding of the key concepts presented in this OPL. The main difference between a Z and T hypothesis test pertains to the amount of uncertainty in the estimate of the standard deviation. A Z test assumes no uncertainty in the estimate of the standard deviation, whereas a T test accounts for any uncertainty in that estimate. Here we see the common steps taken in order to complete a hypothesis test. Shown here are hypothesized means tests. However, the key concepts presented in this OPL pertain to equal means tests and difference of means tests as well. The first key difference pertains to the standard deviation that we use to compute the standard error. In the case of the Z hypothesis test, that value is known with certainty. In the case of the T hypothesis test, that value is usually estimated from the sample data and therefore has some uncertainty. The second key difference pertains to the critical value that we use to decide between the two conclusions of the hypothesis test. In the case of the Z hypothesis test, there's no uncertainty in the standard deviation, and therefore there's only one critical value for the two-tailed test and one critical value for the one-tailed test. In the case of the T hypothesis test, there are varying degrees of uncertainty in the standard deviation depending on the number of degrees of freedom used in the estimate. When there are a large number of samples used to estimate the standard deviation, the precision on that estimate is a very small number. Therefore, it is known with less uncertainty, and vice versa. Therefore, because there are a range of degrees in the estimate of the standard deviation, we have to compute the critical value based on the number of degrees of freedom, as shown in this reduced t-tables in the lower right-hand corner of this slide. It's important to note here that as the number of samples approaches infinity, the precision on the estimate of the standard deviation approaches zero. Or in other words, with an infinite number of samples, the standard deviation is known with certainty. Therefore, we can surmise that the t-test is applicable for any degree of uncertainty in the estimate of the standard deviation, including the case when the standard deviation is known with certainty. So, the t-test is a general case of a hypothesis test, and a z-test is a specific case of the t-test that is only applicable for the condition where the standard deviation is known with certainty. Some of those conditions for which the z-test is appropriate include, for example, the standard deviation is known or given. This may be the case, for example, when the standard deviation is given by the problem or is given by the instructor. Or it might be the case that the problem states that the standard deviation is estimated with very high precision or is estimated with no uncertainty. A second condition for which the z-test would be appropriate is when the standard deviation is estimated with a very high number of degrees of freedom. For example, when the sample size is very large. A third case might be where the standard deviation is assumed to be equal to that of a large baseline sample set. A baseline sample set, for example, might be a large quantity of historical data. In this case, the problem might state that the standard deviation is assumed to be equal to that of a very large baseline sample. Or the problem might state that the standard deviation is assumed to be equal to one that is estimated with very high precision from a baseline sample. In any case, these are all really the same condition. That is, the estimate of the standard deviation is very precise. So, when the estimate of the standard deviation is very precise, the z-test is appropriate, and the t-test is appropriate for any precision. Now let's look at some examples. Determine which test is appropriate for the conditions given in the problem. I suggest first try parsing out what is known about the standard deviation from the problem description, and then checking it against the conditions on the previous slide. Example 1. We're testing a sample mean against a hypothesized value. The standard deviation is estimated from 60 observations. Okay, the problem states that the standard deviation is estimated from 60 observations. This will give us 59 degrees of freedom, which is a relatively large number of degrees of freedom, resulting in a fairly precise estimate of the standard deviation. Therefore, in this case, both the z-test and the t-test are appropriate. Okay, example 2. We're testing a sample mean against a hypothesized value. There are 10 observations. Okay, when parsing out what is known about the standard deviation, we can see that the example does not give any explicit information about the standard deviation. Generally, in this case, we use the sample data in order to make an estimate of the standard deviation. We would have 9 degrees of freedom, and therefore a relatively low precision on that estimate of the standard deviation. So while a t-test would be appropriate, a z-test would not be appropriate. Example 3. We're testing a sample mean against a hypothesized value with a given value for the standard deviation. Okay, here we can see that the problem states that the standard deviation is a given value. Therefore, we assume that it's known with great precision, and both the z-test and the t-test would be appropriate. Example 4. Testing a sample mean against another sample mean where both samples comprise 10 observations. Okay, this is an equal means type of a hypothesis test. All the same rules and conditions apply for determining which type of test is appropriate. The problem doesn't state anything specific about the standard deviation, so we'll assume that that standard deviation will be estimated from the sample data. There will be 20 observations and 18 degrees of freedom, which is still a relatively low precision on the estimate of the standard deviation. Therefore, the t-test will be appropriate, but the z-test will not. Example 5. Testing a sample mean against a mean computed from a large baseline data set. There are 10 observations. Okay, this is a tricky question. Let's carefully parse out what is known about the standard deviation. The problem doesn't state anything specifically about the standard deviation. It does say that the mean is computed from a large baseline set, but doesn't say anything about the standard deviation. Therefore, we'll assume that the standard deviation is estimated from the 10 sample observations, that there will be 9 degrees of freedom, and that the precision on the estimate of the standard deviation will be relatively low. Therefore, in this problem, the t-test is appropriate, but the z-test is not appropriate. Example 6. We're testing a sample mean where the standard deviation of the sample is assumed to be equal to the standard deviation that is estimated from a large baseline sample. Okay, this is a fairly confusing problem, so let's first carefully parse out what is known about the standard deviation from the problem description. Okay, first, the problem states that there is a standard deviation that is estimated from a large baseline sample. Okay. The problem also states that there's a standard deviation that is estimated from the sample. So there are 2 standard deviations. The standard deviation estimated from the large baseline sample will be a fairly precise standard deviation. The standard deviation of the sample is assumed to be equal to the standard deviation of the baseline sample. So we're assuming that they're equal. If the standard deviation estimated from the baseline is known with great precision, therefore the standard deviation of the sample is also known with great precision. Okay, in this case, since the standard deviation of the sample is assumed to be known with great precision, both the z and the t hypothesis tests are appropriate. Okay, let's summarize with some key takeaways. The main difference between the z and t tests pertains to whether or not there is uncertainty in estimating the standard deviation. A z-test assumes no uncertainty in the estimate, whereas a t-test accounts for any uncertainty in the estimate. In a t-test, the critical value varies based on the precision of the estimate of the standard deviation, by virtue of the number of degrees of freedom. A t-test is always appropriate. It's the general case. A z-test is only appropriate for some conditions. It is a specific case of the t-test. Okay, if you have any questions or comments about this OPL, please contact me at this email address.